Hello. Uh, okay, so after a long break from Leetcode, uh, I am going to solve today's Leetcode daily on 17th January. It says 8 hours left. Okay, so it actually has a timer. Okay. So this week was very busy with all the work and stuff I had to do. Uh, and barely got any breathing room this whole week. So let's go and give this a shot. And from now onwards, I would like to say that the daily problem, well, I will put the link, but if you want to figure out for which day I was solving the problem, you can, okay, well, yeah, it's not really accurate. Okay, so what you can do is you can watch the first 1 minute or maybe 2 minutes of the video, and somewhere in that time frame I will be on this problems page where you will be able to see the calendar. But um, well, I will just make it easier. From now onwards, I will include the date of the problem on the thumbnail itself, so that if you are trying to look for a solution, or if I am trying to look for a solution myself, uh, I know which day it was for. Well, for me, it won't be very relevant because I won't be visiting the problem very soon after solving it. Maybe I'll visit it after a few months or so. But for someone else who wants to like refer to the solution maybe a day or two after, they would like to know which day the problem was on. Okay, so let's get started with the problem. And I'm a bit tired as well, so let's hope it's not too hard of a problem. Oh, so today we have a bitwise XOR problem. Interesting. And let me open up my stuff. Sorry. So after a long time, we don't have a string problem. We have a bitwise XOR problem. That's nice. Okay, so okay. Um, yeah, so I will make a folder. I'll make my txt file, and let's hope that today maybe I will. Well, I think today also we can do away with just using our text box and just through typing. Uh, Maybe one day I will be able to use my mouse to draw stuff. Maybe someday when we get a graph problem or something. Okay, so it's day 6 for me, but it is actually not day 6 from when I started. All right, so let's begin with the problem by understanding the problem. And I have my handy text file here. So yeah, as I was saying, this is day 6 for me, but it's not officially day 6 in the series. It's like several days, like at least 4 or 5 days after day 5. And you have to still upload day five's video. It's not a very important video. The problem for day 5 was very easy. Okay, so we have this problem. A zero indexed array derived with length n is derived by computing the bitwise OR of adjacent values in a binary array original of length n. Okay, okay. So okay, we have this derived index zero index array which we got by doing bitwise OR on adjacent values in a binary array originally of length n. So they are not describing it formally. Yeah, yeah. Okay, so if I n minus 1, then derive I equal to original I XOR original 0. Otherwise, it's okay. So it means let's read the complete problem. Given an array derived, your task is to determine whether there exists. Wow, I think Leetcode has started a trend for these. I don't know who is submitting these problems for dailies, but I feel like someone behind these problems or someone in the problem setting community is highly influenced by the competitive programming community or something, because I don't think Leetcode is supposed to promote these kind of problems. When I come to Leetcode, my thought process is like I'll be solving something that requires some thinking, but has more to do with implementation and coding and thinking how will I design the solution. But now we are here again with another problem. I mean, I will cheat. How will I cheat? I will look at the acceptance rate. So yeah, so I mean, it already says that the problem is supposed to be a very simple problem because the acceptance rate says it's 78%. Honestly, there should be I don't know, there should be a way to hide this, maybe. But I mean, it's okay. In contests, you won. Well, in contests, also you kind of get you get this attribute in a more numerical way. You get some people, how many they've submitted and how many are getting accepted. So on lead code, this is kind of unavoidable if you just don't hide it. If you want to hide it, you can do that. So my advice is for this, you should like try watching this thing maybe after a little bit, after trying the problem for a bit. So at least if you have been trying for some time and the acceptance rate is pretty high, then you're doing something wrong. Okay, so back to the problem. Okay, so we have. So as I was saying, these kind of problems, return true or false. Some array is being constructed from another array by doing some math operation. These kind of things usually. I mean, I think I do see these kind of problems as well, but maybe it's just my luck that I've been coming across basically across zero implementation problems so far. No, not zero, but like zero actual, implementation logic oriented problem so far. This is the sixth problem, and we are here again. But well, we cannot really say. Maybe this problem requires some amount of coding and implementation, but well, it doesn't look from this. So let's okay, enough talking. Let's just get into the problem. Okay, so your task is to determine whether there exists a valid binary origin that could have form derived. Return true if such an array exists or false otherwise. Okay, so binary array has zeros and ones. I think the question is pretty clear. This point only says like if your index is zero, then derived zero is formed using original zero and original one. Similarly, if I is n minus one, then there is no index equal to n, so they use n minus one and the first index by rolling it over. Okay, so let's think about the problem. What we can do. So our input is derived, and we want to think if there is an original that allows us to do this. Uh, so right away, the most obvious thing that strikes my mind is I can always just if I start from the zero index, like the most obvious and probably wrong idea that comes to me, oh, okay, stop Windows, stop bothering me. Okay, so the most obvious thing that I that strikes me is like, let's say you have index I, and derived I is equal to let's say zero. So if let's say I've already fixed my binary I, let's say I fixed it to be 1, this is fixed, then I can choose binary I plus 1 to be equal to 1. Basically, I plus 1 is flexible. Up to, we also need to mention up to what end, up to, so up to index n minus 2, this is fairly flexible. We can always choose to, uh, so if our ith index is fixed, we can easily just according to what the value derived I is, we can already get I plus 1. And if we want to get I plus 1 in this way, uh, let me put the title to this approach, probably wrong approach. Okay, so we can simply get our binary I plus 1 uh, with simply by XORing binary I with this symbol is bitwise XOR symbol. Sometimes it's also the symbol for exponent, but it I cannot write this weird. Okay, let me just copy this funny looking symbol. This is basically OR plus. I don't know what the symbol means, but there is something about OR and the plus operator together they used to define as OR. Forgot how exactly that works, but anyways, so this is the symbol, and we just need to do this derived uh, derived I of. So with in this manner we can fix our I plus 1 up to index n minus 2. And for n minus 1, since both indexes 0 and n minus 1 are already fixed, we just need to verify uh, uh, just need to verify if binary n minus 1, sorry, derived n minus 1 equal to binary n minus 1 or binary 0. Oh, sorry. Yeah, so we just need to verify this. If this probably wrong approach works, then we just need to do this and our problem is done. If derived n minus 1 matches, then we return true, otherwise we return false. If this holds, return true or return false. Okay. So as I've said time and again with such problems, you cannot just put a random approach and claim that this is correct. You have to support it with some evidence. You have to support it with proof. So we will think if this approach is correct, and like if it is, we have to prove it. If we cannot, then we try to find a counter case and we think in some other direction. Simple. All right. So now let's think, how is this happening? Hmm. So we can, if we think about our original array, let's say we have a binary array that. Okay, so let's forget about the derived array. Let's think about a binary array. Let's take an arbitrary binary array and see what we can do with it. Yeah, the text box. Let's say our binary array is equal to, well, let's take length 5, so let's 0 1 1 0 1, something like this, and our derived will look like, so I will take adjacent XORs, so we will have 0 1 comma 1 XOR 1. Then I will not put spaces because pointless time consumption. 1 XOR 0 0 XOR 1, and finally 1 XOR 0. Wait, let me just confirm. Yeah, so I think it's obvious how I did. I took XORs of adjacent and I followed the same condition for the last index. We took with the last index and like n minus 1 and 0th index. And let's actually write it down what our words are. Uh, 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 okay. What is happening? Oh, acha. Right. Stop. Mm, just a second. Yeah, okay. Now we are okay. All right. So let's write down what it is coming out to be. So it's coming out to be 1, 1, 1. This is our array, the derived array that we got after doing the operation, the bitwise XOR operation. Just checking once to confirm that I've put the values down correctly. All right, let's put the binary array in a circular form. So, okay, nice. So now we can actually use some doodling, some actual doodling. So let me pick up pencil. Okay, so this is the first time I'm actually doing some doodling. So it's going to look really funny and pretty bad. So don't laugh. Okay, let's pick a brush. Brush is thicker, and let's pick a bolder stroke. All right, so let's think about a circle. Let me draw a circle. Okay, not a very bad looking circle. And let's place our numbers in a circular ring form. So we have 0, we have 1, we have 1, we have 0, and we have 1. All right. So if you go in clockwise direction, that's what our array is, the binary array. 0, 1, 0, 1. Okay. Now so we got this derived array out of our operations. Now, is there a way to like modify this ring so that we get this same derived array again? So, or yeah, it's like why I will discuss why I'm trying to do this. Yes. So if we like want to maintain the derived, and let's say we flip 0 as 1. So now since the second digit was 0, we now have to flip this to uh, wait. So we flipped this, yeah. So since the first was 0, we flipped it. So now we have to flip the second to 0, right? So now we'll get 1 0 0. Basically, instead of 0 0, we'll get 1 0 0, and we'll still get 1 again. Now, since this is 0 and our derived index 2 was 0, so this third index needs to be 0 as well. So I think it's obvious what pattern it is following. It's basically inverting all the bits. So I'll just write them down. So you can confirm it by pausing the video, but you'll get the same answer. So as you can see, all our bits got inverted if we had to maintain our derived array 1 0 0 0 0 1 1 0 0 1. Okay, so what does this mean? So uh, so this basically means for any derived, for any possible derived array, there are basically exactly two solutions that can actually satisfy, two binary arrays that can actually satisfy the solution, right? There's only two binary arrays that can satisfy the solution. And also, the two binary arrays are basically complement of each other. Complement in the sense, so uh, let's write down this new binary array that we got. Why am I why am I why am I writing it with the brush? Okay, so let's put it down as binary array complement. Complement is 1 0 0 1 0. And if you look at binary array and binary array complement, if you take source of same index elements, right? If you take source of same index elements over binary array and binary array complement, you will find that all the combined the XOR of ARR and ARR complement shorthands for binary array and binary array complement is basically just all ones. Okay, right. So basically, actually this information is not very useful, but basically I was just showing it in a visual way how the bits are coming out to be. So basically they are complement of each other. Each element is coming out in such a way that the two like the both the solutions are of such nature that if you come took a XOR across them, you would get one. So effectively, what we have to do is, I think it's quite obvious that we must first try to fix an index. It can be any index, but for our convenience, let's say index zero. Just give me a moment. Just give me a moment. Okay. So yeah. So as I said, so what we can do is fix. So as I said, we can fix any index, but let's try by fixing index zero. And when we fix index zero, basically we choose some value. Let's say we choose anything, one or zero. So as I said, from our probably wrong approach, we can basically take out all the digits, right? We can take out all the indexes through zoring uh, index I on derived and index I on binary. Yeah, I've written it down to get I plus one, and we can in this way get our possible original binary array. Now, as I said, we can just verify. We can verify if derived this is working. If derived, if this condition holds, then obviously we have found our array. All right. Uh, in case that does not work, in case that does not work, uh, we will not, for a moment, let's not think too critically. So we can basically do this. We can fix the first digit, and when we fix the first digit, we basically get the rest of the array. It's fixed as well. We use that to verify. Use so one use fix index zero equal to zero. Let's fix it at zero and find the possible binary array. 1, 2. If that does not work, then try with index 0 equal to 1 and find possible binary array 2. If it still doesn't work, then return false. Right? So this is pretty easy because as I said, I already showed that there are only two possible answers that can basically work, and the two possible answers have to be complement of each other. So uh, yeah, so the two possible answers have to be complement of each other. So actually, I think we don't really need to do approach two because it's clear that if binary array one works, then binary array two also works. And I guess it's also correct to say that if binary array 1 doesn't work, then there is no way binary array 2 is going to work because that's basically us just exactly inverting the bits. So effectively, the XOR of the n minus 1 position will not change. So the approach is basically basically remove this approach, not needed. Yeah, so effectively we don't need approach 2. We can just fix index 0 equal to 0 and find the possible binary array 1. If it does not work, then return false because the only other alternative is exactly the same. Okay, so yeah, it's quite simple, and let's just there's only two hints for this problem. So okay, what if wait, I have it solved. Now that sucks. How many days or years or weeks before did I solve this? It was solved by me nearly 1.5 years ago. Okay, I think this came in a contest probably, like a problem B or something. Okay, so let's go with it. So I think we can also simplify. I mean, the total time complexity is O(n) and memory is well nothing constant. I think there is a maybe a better way to solve this problem, but for our case, we'll just do exactly what we have written down. Find our binary array through this process and just verify this condition. Okay, so let's begin our code. So the code is basically first we take vector in binary. Let's say bin arr, and let's take the length of this int n equal to derived. I think we will get to see some interesting insights for this problem, or maybe we'll not get to see anything at all in the solutions section. The problem looks quite simple, but you never know with these kind of problems. Although I'm fairly confident, like I'm 99% confident that this solution is correct because we have kind of explored all the possibilities surrounding any fixed derived input. All right, so let's go. So we will start with what did I write here? So I wrote binary I plus 1 is equal to is flexible, right? So first and foremost, let's fix bin, just a moment. Yeah. So let's first fix our bin array 0 to be bin arr 0 to be 0, and we will just go from uh, int I equal to 1 from index 1 to n minus 1, and we will simply do what we pasted, basically uh, bin arr I is equal to bin arr I minus 1 XOR derived derived I minus 1. We will return false here. Like if I'll write a check, if that fails, then just go and return false. Return uh, we are returning if bin arr, sorry, we are returning if derived minus 1 equal to, we'll have to put braces because bitwise or is a weak kind of operator. So I think even if we don't put parentheses, it is okay. But let's just do that. Do it for precaution. Okay, so this should be equal to bin arr n minus 1 XOR bin arr 0. So if this holds, we return true, else we return false. Excuse me. Okay, so runtime case sample cases are okay. Let's submit it. Okay, so yeah, this works. This, in fact, we didn't need this actually. I think, yeah, we could actually cut down the space. Okay, okay, so there is room for improvement. So let's discuss that. So we took an n-sized bin array, but in reality we didn't need this. We all we needed is to know the previous value. So let's just put it like int prev. By prev I mean the prev I mean you need derived I minus one. Sorry, I mean this is bin arr I minus one basically. So simply uh, we put a curve. We will also put int curve, which is initially zero. I'm just initializing with some value. Current means the you know bin arri. You can optimize the memory in this way. In fact, I would say this problem is in okay. I mean, this can be an interview problem. Wow, 1,400 test cases, crazy. This can be an interview question because this is in interview pressure. You could actually mess this up. But otherwise, even if you do manage to solve it using an n-size array, the interviewer will definitely ask you a follow-up to optimize this. Okay, so and as I said, this is O1, but it became O1n memory-wise. But now we are bringing it back to constant memory. Okay, so we are now going to do this car equal to prev zord derived I minus one, and then you will do previous is equal to current. This is a very common technique you use in like one-dimensional DP or one-dimensional prefix sums. You know, you want to cut down the memory sometimes. Then we use this trick, and obviously we simply do current equal to this. Uh, Actually, not. Uh, Wait, what was written here? Okay, okay. So we need bin array zero. So yeah, we will have to actually store. But uh, I actually fixed bin array zero to be zero, right? Yeah, I actually fixed bin array zero to be zero. So we don't really need this because I already fixed it to be zero. In fact, you don't need bin array zero because bin binary array zero is something you only fix before starting. And since I took zero, just for the sake of understanding, I put a zero here. It does not make any difference. And we just need this. Okay. So now let's check again, our time solution. With samples, and then let's submit it again. Okay. So this is okay. Now let's try submitting this. Okay. So we cut down the memory by a good amount, and we have managed to Uh, the memory also we have managed to cut down a lot. Still, it says only 74%. That's interesting. Um, I'm not sure how exactly people did this, but I'm thinking, well, this is basically constant memory, and for interview purposes, this is basically more than enough. But um, maybe there are some interesting approaches to solve this problem, like not using traditional ways, maybe some data structures, which we will view in the solution. So we have done our memory, we have fixed the memory. Let's have a look at the ends description. Uh, so I'm guessing understand this. That one we are using each element twice to construct the derived. Yeah, that is true. We are using each element twice. That is quite true. The XOR sum of the derived array should be 0 since there is always a duplicate occurrence of each element. What does XOR sum mean? Hmm? What is a XOR sum? Let's Google. Oh, okay. Not sure what they mean. The XOR sum of the derived array should be 0 since uh, there is always duplicate occurrence of each element. Duplicate occurrence of each element using binary array. Um, wait. Let's go through hint one that from the original we're using each element. Yeah, we are using each element to be constructed twice. So x1, x2, x2, x1. Uh, oh, okay. I think I understand what they mean. They mean we should take XOR of whole array, like the derived, and we will get 0. Oh, this is actually a pretty. I think this is also a pretty cool way of coming to the conclusion. So basically, the hint says that since every element comes twice, how does it come twice? So like your original I comes once for derived I, and then it comes for like it comes in derived I minus one, and it also comes in derived I, the original I. So if you take bitwise XOR across the whole derived array, you will also get like the whole answer will be 0. Like to put it visually, let's just use our example. So we had our binary array. We had our binary array, and this is what we got, right? So if you see, these numbers are basically repeating. One is repeating twice. This one is repeating twice. This zero is repeating twice. This one is repeating twice. This zero is repeating twice. So now if you take the XOR of this whole thing, every element cancels each other. One XOR one, one XOR one, one zero XOR zero, one XOR zero, one XOR one, zero XOR zero, and ultimately you get the whole like XOR sum of the derived array is zero, basically consecutive XOR on all elements. So you can use that as well to solve the problem. In short, uh, uh, but I wonder if that is conclusive enough. Like if the XOR comes out to be zero, then your answer is true. Otherwise, it's false. Uh, I think maybe it is conclusive enough if this happens. There are some similar questions. Easy. Mm, well, definitely that's a necessary condition that has to happen. You definitely need that to happen. Otherwise, uh, there is no way you can get an input. But is that sufficient as well? Like it's necessary that the derived arrays or sum is zero, but is that sufficient? Mm, let me think. Uh, x1, x2, x2, x3, x3, x4, and so on. If that happens, that means there is some x1, x2 that works. So, right, right. So there is, so you can fix x1 and it fixes both the ends. Ah, okay, it works. Yes, it does work. How it works, let me put it visually. Yeah. So basically, Since every value is repeating twice, let me put how the values are repeating. Here we are using zeros and ones, but let's put it visually. So how it's repeating? It's repeating like this: 3x4, x4, x1. So we can let's draw another circle to show how it's actually working. It's this one's gonna be a little weird looking circle. Should we cheat and use oval shape? Or no, let it be. I don't cheat. I don't use chat GPT. I will just make the circle. Okay. So let's go and make a nice looking circular circle. This is a very nice looking circle, except it's almost oval. And this time I will also use my pen to try write the letters x1, x2. Oof. How do people use mouse to type to like write things? I don't understand. X3. Why am I spacing them? Because the first element is formed using first, second. The second element is formed using second, third, and so on. That's why I'm spacing them like this. X3, X4. Okay, we do only four, but I will draw five. X4, X5. Wait, let's put it clockwise only. Why are we going anti-clockwise suddenly? And finally, we have X5 and X1. Okay, so I put it on a really nice looking circle. And as you can see, they say if the derived array's awesome is zero, then that is it. We don't need to do anything else. So as you can see, if that is true, then that means every element is coming twice in this fashion, right? And now in our approach, what we were doing is we were fixing this. We were fixing this, which means this is fixed as well, right? Now, if this is fixed, then x2 is fixed, x3 is fixed, x4 is fixed, and x5 is fixed. But as you can see, there is no conflict. Yes, it's true. If we fix x1, every other letter gets fixed, but there is no room for any kind of uh, um, contradiction because every element is coming twice irrespective, right? Once we fix x1, we fix x1, so this causes uh, x2 to be fixed, x3 and x4 expect to be fixed, but it makes sure that everything comes twice and there is no room for any kind of contradiction. So at least visually it makes sense that if we just verify that the derived array draw is zero, then we are done. Because the derived array having draw zero means it's following this figure that we draw, that we have drawn, and that is correct. We want everything to be twice without any kind of problems. So let's make this problem even simpler. And this is actually quite a nice problem. If your interviewer says, like, okay, your approach looks cool to me, you use two integer variables and you know, uh, did this and you return false. But there is an approach that works even better or even simpler. I hope the interviewer really does not ask that because at that point he's harassing you. But let's say if you're discussing among friends, then someone says, okay, but I have a cooler approach than this, then just for brag points, you can use special these Leetcode things and do that. So let's make it even simpler. We don't even need any of this anymore. We don't need binary array. We don't need anything. All we need is In fact, we don't need to use any space at all. We can simply do this. Return. This will make sense in just like another 10-20 seconds. We don't even need to do this. We just need to do derived I XOR equal to derived. I'm just using the original array to my benefit to calculate the XOR sum of the whole input. How it works is simple. It's for ith position, it is XORing with its previous value. So for if you are to simulate this on paper for index 1, you will get index 1 XOR 0. For index 2, you will get index 2 XOR derived 1, which is equal to index 1 XOR index 0. And likewise, if you keep continuing, you'll get all the way till derived n minus 1. So finally, when we XOR in this, fashion, iterative fashion, our final derived n minus 1 should become 0. And if that happens, we are done. So let's run and check. So this is correct, and let's submit. So as you can see, we we were able to make it even easy. I mean, let's be honest, this approach is not that simple. It's straightforward, but you may not be able to come up with this on the spot. But yeah, if you are doing code golf, then surely there is no. Actually, why do we even have this return false here? We don't even need this anymore. We don't even need this anymore. I will base Leetcode's uh, computation just for cool points. So yeah, we don't even what why did the memory become slow less all of a sudden? I think Leetcode is just trolling. Yeah, Leetcode is just trolling. I mean, at this point, the memory usage probably depends on random factors because we are basically using no memory. So yeah, so if you are doing code golf, then this is a cool very fun, nice solution. And yeah, that's it. This problem is over. So let's quickly have a look at the solutions. From now onwards, I think I should mention the timestamp when the problem is actually over. And so it's 48 minutes. I'll put the timestamp where the problem is done, and I'm just basically just having a look at what people have to say about the problem. Editorial is there. Overview, intuition, whatever. They are purposefully, they know they can do it in one pass, but they have to, show you different passes. Where once you are not using extra memory, and once you are see, this is what they did, exactly what I did. 0101. There are actually a lot of ways to solve this problem actually. So yeah. How is it sufficient? See, exactly the same question that like I also asked. It's a necessary condition, but how is it sufficient? So we drew the visuals and we, convinced ourselves that that works. But let's see what people have to say in the replies. So this is not an explanation because using a different approach does not explain. Here, there's a correct proof. He says if we rewrite condition from the statement, we obtain this. Right? See if we take then we will get the whole array by induction. Although okay occur in the dn minus one rewriting this or Yeah, yeah. Just a moment. He says if we expand this thing, the condition, then we get this, and we can see that everything is cancelling out except for this, which is the same as saying this. And now equations hold. The actually show doesn't matter what is zero, should we pick zero. You can check this f a and uh, this approach is a and minus one. Check for zero variable. What is that variable? Check for zero. Yeah, we did this, right? We did this. This was like our very first approach. Was basically that. I'm trying to understand how is this a proof? Just trying. He is correct up to this step that yes, we can expand this like this, and we can basically cancel out almost everything. And okay, okay. He's just saying this should hold, and we already know that this is what we were providing problems, so everything holds. So yeah, so somebody asked, I think somebody asked, why is this a sufficient condition as well? So, as he said that if you expand all the elements, you get this, and uh, uh, this this condition actually implies this condition, and since this was given to us in the problem, therefore just checking for this is sufficient. Basically saying if you restate this condition, restate this was given to us in the problem that this has to go. That basically means this. Now you backtrack from here and you basically get this again. So yeah, so this is necessary and this is also sufficient because the problem explicitly asks you in a roundabout manner to do exactly this. But if this is not convincing, then obviously there is the figure, the way I explained the solution. But I think this is good enough because this is basically saying that yes, the author or the problem set has told you that you have to basically check this only. This condition is the only way your solution will hold. So he explained it by saying that if we go backwards from what we had originally, we'll basically come to this condition itself. That is why this is also sufficient. But let me just think for 2 minutes more. Personal clarification. Yeah. So in our problem, basically, when we were going through approach one, we basically wanted to check for this, right? Finally, we wanted to check for this if this holds true. And surprisingly, due to the nature of problem, this turns out to be exactly this. If you go from reverse, so that's why you're basically checking this condition twice. Or basically, if you are checking for that this condition, it's the same as checking this condition. And since we know this condition, this way of checking our solution is correct, so this is also correct. This verifying this is also correct. Uh, he says this is insufficient. Okay. This is replying to someone else. Hmm. Yeah, the problem can occur only in the n minus one. We fixed all of them to be put to this. Yeah, the problem can only occur in this. We see these all are cancelling out, so we have to check. This is the equation that is left finally, and this is same as stating this. Now all equations hold. Right, right. If this holds, then only this can hold, and we want this to hold. In fact, no, I mean, no, not necessary. There could be some other solution, but if this holds, then we know this holds, and this was the only problematic value that we were not sure of. Everything else is correct. We can fix and we can find it, but this was the only value we were not sure of. But because this condition, if we make this compel, this is like if this condition is sufficient, because when we have this condition true, then we have this also true. And this is what the problem was also saying, that uh, for any such derived n minus 1, it has to be the XOR of 0 and n minus 1. So if this condition holds, naturally we also get this, is the problem stated. That is why this is enough, like this is sufficient as well. So let me restate it finally without prolonging this video anymore. To speak in simple words, because the bitwise XOR sum of the whole array being 0 is a valid condition. And how is it valid? Because if this condition holds, then this also holds. And for every other element, d0, d1, dn minus 2, we can always construct, like we can always correctly construct them by using our values, by using some values for the binary array that we can flexibly we can choose. The only problem was in dn minus 1. So for dn minus 2, everything was fine, no problems. But because when we followed this condition, we got this condition y. Let's say this is condition y, this is condition y, and this condition y was the condition that needed to be true for n minus 1 question. If you look at the description, it says that the derived I must be this. I'm sorry, derived I must be this if this is the case. So all our equations are holding simply when simply when this condition holds. That's why this is sufficient as well. Okay, well, to be honest, I will put the timestamp. Like you don't need to watch more than the last 5 or maybe in the last 4 minutes to understand why it's proof is correct. This explanation is good. I put. I don't know if there is a way to share this. I will share this link for the proof. This is more than enough. Same question is asking, but the proof is already above. Basically, he went XOR 0 instead of XOR 1. This is not correct. He's saying that the last equation satisfied. I don't know what is the equation, but okay, maybe for his case this is true. But anyways, for our case, it was that if the XOR of all the elements is 0, then we get condition y, which is saying the value of dn minus 1 is XOR of original 0 and original n minus 1, which was exactly what our problem wanted us to follow. And since that is naturally following from everyone, every XOR becoming 0, it is also sufficient. So we are done. So no point in reading anymore. Man, what coding problem. Anyway, so no need to go too far into the solution. This solution is enough. Just take it slow and read this, and you will have it. Or you can definitely go through this approach as well as I've told. That if you fix these values, everything else easily gets fixed without any problems. There is nobody is like restricting anybody else, and we can still get our zero value. So use this solution and use this visualization to convince yourself that this works. All right, so we are done with today's Leetcode problem. I would say it was very simple, normal, and but yeah, in an interview, if this problem counts, and if your interviewer is not very straightforward and you want to be very thorough with your explanation, then you may have some trouble. So usually problems like these shouldn't come in an interview, but if they do, then you must be very clear with the explanation. You must explain for these kind of problems. You need to explain the necessary condition, and you must, if the necessary condition is also sufficient, you must justify that. So we went through that, took some time into convincing ourselves, and we are done. So yeah. So that's it for this problem. Bye bye.